Welcome to Next Gen Manufacturing. Today, we're diving into one of the biggest, most high-stakes challenges in the entire industry, trying to predict the cost of a new product before it even exists. I mean, if you get this wrong, a project can be in deep trouble right from the get-go.
So yeah, this is it. The big one. It's the question every single person asks, from the engineers to the managers to the clients. It's usually the first question, always the last one, and honestly, it's the hardest one to answer with any real certainty. Pretty much everything hangs on this number.
But here's the crazy part. Get this. A staggering 70% of a product's final cost isn't decided on the factory floor. Nope. It's actually locked in way earlier, during the design phase, back when the product is basically just a drawing on a screen. Just look at this breakdown. The choices you make in that initial design phase, they have a massive 70% grip on the final price. All the other stuff, the materials, the actual labor, all that hands-on production work, that's just the last 30%. And that right there is why getting an early cost estimate isn't just, helpful. It's absolutely critical. Okay, so here's our game plan. We're going to start by really digging into that 70% problem. Then, we'll break down what actually goes into a product's cost. From there, we'll look at the 3 classic methods the pros use to crack this nut. And finally, we'll see how those old-school ideas are evolving into the AI-driven tools of today. So let's just hammer this point home. Once you're past that initial design, making changes gets expensive. And I mean fast. A little tweak on day 1 might cost you pennies, but that exact same tweak a month before launch, that could cost you millions. So these early estimates, they aren't just guesses. They're the financial guardrails for the whole project. And this really requires a huge shift in thinking. You see, in modern manufacturing, cost isn't some afterthought that the finance department deals with later. No way. It is a fundamental design parameter, just as important as the material strength or the operating temperature. It's an engineering problem, through and through.
Okay, so before we can even try to predict a cost, we have to agree on what we're actually adding up, right? What are the core ingredients that make up that final price tag?
In the industry, they call this the technical cost price, and it's basically made of 3 main slices. The biggest piece of the pie, usually about half, is your supply costs. That's all your raw materials. Then you've got subcontracting, for any work that you have outside partners do. And finally, manufacturing costs, which is all the work you do right there in your own shop. So how in the world do we estimate that total? Well, let's look at our first method. This one's the most traditional. It's the most detailed, and I like to call it the by-the-book approach, the analytical method. The logic here is pretty simple, right? You take a huge, complicated job, break it down into 1,000 tiny, predictable little steps, put a price on each of those tiny steps, and then just add them all up. It's kind of like building that flat-pack furniture from a super detailed manual, where you account for every single screw, every dowel, and every minute of work. So here's the trade-off. On one hand, this method is incredibly precise. You get a number you can have a lot of confidence in, and it even lets you spot ways to make the whole process better. But on the other hand, it takes a ton of time, and you pretty much need a finished design to even start. It's powerful, for sure, but it is not fast. But what if you don't have all that detail yet? What if you're way earlier in the process? Well, that brings us to method number 2, which is all about experience, not spreadsheets. This is the find-a-twin approach, also known as the analogous method. So instead of building the price from scratch, you find a really similar product you've made in the past and you use its cost as your starting point. It's exactly like pricing a house by looking at what similar homes in the same neighborhood just sold for. You take that historical price and then you make some smart adjustments for all the little differences. And what's wild here is that the pros and cons are basically the complete opposite of the last method. This approach is super fast, and you can use it really early on when you barely have any information. The catch? Its accuracy totally depends on your old data and just how similar that twin product really is. You get speed, but you give up precision. Okay, so we've got the slow but precise method and the fast but fuzzy one. The third approach tries to find a happy medium using pure data. Welcome to the formula, also known as the parametric method. This method totally ignores the process steps, and it doesn't care about similar products. It only looks for statistical relationships. Think of it like an algorithm that predicts a flight's price based on things like the destination, the time of year, and fuel costs.
By crunching the numbers on hundreds of past projects, it literally builds a formula that connects key parameters, like weight or material, directly to the cost. And this is a perfect example of how it works. This is real data that was used to build a cost estimation formula for engine pistons. The algorithm just analyzes this table to find the mathematical link between inputs, like diameter and height, and the output, which here is manufacturing time. And that's a direct stand-in for cost. Now, the big advantage here is that it's fast and totally objective. It can clearly show you which design choices are driving up the cost. The downside? It can kind of feel like a black box. It gives you a number, but not always the why behind it. And because it's based on general trends, it can get tripped up by really unique, one-of-a-kind designs. So we've got our 3 foundational methods: buy the book, find a twin, and the formula. But hey, this is next-gen manufacturing, so now we've got to connect these classic ideas to the tech that's completely changing the game today. Let's go back to that find a twin method for a second. Researchers describe it as finding patterns based on a product's shape, its dimensions, its technology, all to predict its cost. Now, does that process, sifting through a bunch of past examples to make a prediction, does that sound at all familiar to you? It totally should, because that core logic, finding similar cases from the past and learning from them, is the exact foundation for what we now call artificial intelligence. These systems are often called case-based reasoning, and what used to be an expert's intuition is now an algorithm's main job. And this, right here, is the key takeaway for today. Each of these classic methods was basically the seed for a powerful modern technology. The find-a-twin method, that grew into AI. The formula method evolved into sophisticated machine learning models. And that super detailed by-the-book method, it provides the DNA for digital twin simulations, these incredible virtual copies where we can build and test an entire production line before a single real screw is ever turned. So we've basically watched cost estimation transform from an art that was based on experience into a science that's driven by data. And that leaves us with one last really fascinating question to think about. As these powerful algorithms get better and better at mastering the science of calculation, what's the new role for human intuition and expertise in the factories of the future?